ClearInfra. Efficient by design, intelligent by nature.
Hey there, and welcome to ClearInfra University. In this explainer, we're going to dive into a really core concept in building physics, solar heat gain. We're going to break down what it is, how it actually works, and most importantly, how we measure it. So, let's jump right in.
You know, it's easy to think of buildings as these static, unchanging objects, but the truth is, they're constantly interacting with their environment. And the biggest player in that environment? It's got to be the sun. Every single day, our buildings are having this sort of dynamic conversation with solar energy.
Now, that conversation is pretty complex, right? It involves heat and light and all sorts of different materials. So, for this explainer, we're going to zero in and translate just one specific part of it. What happens when all that energy from the sun meets the glass in a window? Okay, so the first crucial thing to remember is that sunlight isn't just light, it's a really powerful form of radiant energy. I mean, it travels millions of miles through space, and a tiny piece of it arrives right here on the surface of our planet, striking the outer skin, or what we call the envelope, of every single building. All right, now let's zoom in from the whole building down to just one part, a single pane of glass in a window. When that solar energy shows up, the glass doesn't just, let it all in or keep it all out. Instead, it acts like a kind of gatekeeper, and it gets to decide what happens to that incoming energy. So, what are the options for this gatekeeper? I mean, when solar energy hits the glass, it has to go somewhere. It turns out there are really only 3 possible paths it can take. Let's take a look at each one.
So the first path is reflection. This one's pretty straightforward. Just like a mirror, the surface of the glass bounces some of that solar energy right back out into the environment. It never even gets a chance to enter the building.
Okay, path number 2 is absorption. Now, some of the energy doesn't bounce off, and it doesn't pass through either. Instead, it gets soaked up by the glass material itself. This absorbed energy heats the glass, which is exactly why a window can feel warm to the touch on a sunny day. And that brings us to our third and final path, transmission. This is the energy that makes it straight through the glass and into the space inside. This is the direct sunlight that we can actually see and feel when we're indoors. So, okay, we've got these 3 pathways, right? Reflection, absorption, and transmission. But that brings up a really important question. When you add it all up, how much of that original solar energy actually ends up inside the building as heat? Well, the answer to that question is a little more interesting than just, measuring the light that passes through. The total amount of heat that enters the building is actually a combination of 2 of those pathways we just talked about. Let's break this down. First, you've got the energy that's directly transmitted, the stuff that passes straight through the glass. Simple enough. But what about the energy that got absorbed and heated the glass? Well, that heat doesn't just vanish, it actually radiates away from the warm glass in 2 directions. Some goes outward and some goes inward. And that part that radiates inward, that's the second piece of the puzzle. So the total solar heat gain is the transmitted energy plus that absorbed energy that gets radiated back into the room. It's both of those things together. Okay, I know that might sound a little complicated, so let's use a really simple analogy to make this crystal clear. We're going to completely forget about formulas for a second and just think in terms of simple units of energy.
Let's just imagine that exactly 100 units of solar energy are heading toward our window. Think of this 100 as all the solar energy that's available before it has any interaction with the glass.
So, after all that bouncing, absorbing, and passing through, after all those interactions are done, we measure how much of that energy actually ended up inside as heat. And in this example, out of our original 100 units, a total of 45 have made their way into the building. Now, this whole process, this entire journey of energy we've just described, can be summed up with a single, really elegant number. And this brings us to the formal term for what we're actually measuring. It's called the solar heat gain coefficient, or for short, SHGC. It's simply the fraction of solar energy that strikes a window and ultimately enters the interior as heat. So back to our analogy, with 45 units entering out of an original 100, the SHGC is, you guessed it, 0.45. So here's the absolute key takeaway. SHGC isn't a recommendation, and it's not a judgment. It is simply a measurement. It's a pure physical description of how a particular window system treats incoming solar energy, taking everything into account: the transmission, the absorption, and the radiation. It just measures the final outcome.
So we have this one number that tells us the end result of this whole journey of light. But that leads to the next big question, right? What actually happens when this number changes? In our next explainer, we'll explore exactly that, the real-world implications of changing this number, and why it's so critical for building design.